Today, we will take a look at the so-called coefficient of variation in statistics. Like variance or standard deviation, the coefficient of variation is a measure of dispersion in statistics. The purpose of the coefficient of variation is to normalize the standard deviation, thereby enhancing its interpretability, and it can also be understood as a relative measure of comparison. Let's start by looking at the formula for calculating the coefficient of variation. The formula is coefficient of variation equals standard deviation divided by the mean. Thus, the coefficient of variation relates the standard deviation to the mean, which explains why it serves as a relative measure of comparison. Now, let's examine the following example to properly understand the coefficient of variation. We are tasked with calculating the coefficient of variation for the price changes of two stocks from Monday to Friday during our observation week and then comparing them. Let's begin with stock 1. The recorded closing prices for the stock are $20 on Monday, $22 on Tuesday, $18 on Wednesday, $25 on Thursday, and $26 on Friday. As we already know, we need the mean and the standard deviation to calculate the coefficient of variation. For the mean, we get 22.20, and the standard deviation is 2.99. Great, now we can simply plug the standard deviation and the mean into the formula for the coefficient of variation. Coefficient of variation equals 2.99 divided by 22.20, which equals 0.13. To make this more interpretable, we can convert the coefficient of variation into a percentage by multiplying the result by 100. Thus, we get 13%, which means that the dispersion of the stock prices around the mean, or the average stock price during the observed week, was 13%. Perfect. Using the same approach, we can now calculate the coefficient of variation for stock 2. Here the mean is exactly 14, and the standard deviation is 2.19. Plugging this into the formula, we get coefficient of variation equals 2.19 divided by 14, which equals 0.16 or 16%. Even though it might not seem obvious at first glance when looking at the individual closing prices of both stocks, the dispersion for stock 2 at 16% is higher than the dispersion for stock 1. This comparison is easily made possible using the coefficient of variation. By the way, when we are dealing with data on different scales, such as prices in dollars or time in hours, the coefficient of variation also helps us compare the dispersion effectively. We hope this video has helped you understand the topic of the coefficient of variation. See you next time, and have a good one.